Hello, you're welcome once again to Mars Clinic series. My name is Evans O'Day, and we are still looking at the concept of logarithm. In our previous lesson, we were able to define what logarithm is. We asked the very big question, what is logarithm? And we were able to explain that. Today, we are looking at why the need to understand the concept of logarithm. Is it so important in our real life experience? Yes, it is. And so let's go through why logarithm. Okay, so let's start by saying that, okay, logarithm in real life experience, do we see it in our everyday life or in measuring and other aspects of our life? Let's see the first one. Learning logarithm can help you deal with finance and investment. In finance, logarithms are used to calculate compound interest. Take note, compound interest, which is crucial for understanding investment and loans. And all those of us, those of us who deal with loans, banks, we understand compound interest. The compound interest formula involves logarithmic calculations to determine the growth of savings or the accumulation of debt over time. Maybe let's take example and see what we are trying to say here. Let's say you are Kwame or Ama Kofi and you invest amount of 2,000 cedis in a savings account that offers you 5% annual interest compounded yearly. Okay. Now your target is to raise an amount of 3,000 for a project or something. Now we want to find out how many years will it take for the investment that's supposed to be with an interest of 5% grow to 3,000 Ghana cedis. Now our interest here is not to solve this question. But the interest is to see where logarithm play a crucial role when you want to handle question like this. If I give you this a chance to solve this question, I'm sure you can use your knowledge in business mathematics to solve this question. But then at a point, you need the concept of logarithm. We know this formula already from our percentages lesson that total amount that you will accrue, let's say the 3,000 is equal to the principal that you invested, okay, into bracket 1 plus the rate that has been given to you, and then the time it will take for you to get the maturity of your investment, or the T. Okay, so we are saying that if you make substitution into this formula, putting in the amount you are supposed to acquire at the end of the number of years you are thinking about, and the principal is put in place, the rate is put in place. Remember, the rate is 5%, which means 5 divided by 100. Now you want to solve for the value of t to know the number of years it will take you. In trying to solve this question, you simplify by dividing both sides by 2,000, and then you get something like 1.5 is equal to 1.05 t. Now this is where logarithm comes in. You want to make t the subject. Being an exponent, it will be a bit challenging to solve. So the easy way out is to take log to both sides of the equation. And that's where the logarithm comes in. And your knowledge in logarithm, based on what we are going to learn in our next video, you realize that this t here can move to become a multiplier to the log 1.05. So when you divide both sides by log 1.05, then you can make t the subject, and that will give you approximately 8 years, so that if you keep this money 2,000 in a savings account of 5%, it will take you 80 years before you can raise an amount of 3,000. Right, so that is a fair deal. This is why we need to understand concept of logarithm for such calculations. Again, logarithm also helps in measuring earthquakes. Okay, we all know earthquakes occur in different parts of the world, and sometimes they tell us the magnitude of the earthquake. Now, in this very instance, we want to see how logarithm comes into play here. Now, what it says is that the Richter scale used to measure the intensity of the earthquakes, and it is based on logarithm. Each whole number increases on the Richter scale represent a tenfold increase in the amplitude of the earthquake's seismic waves. Okay, so let me give you an example to see what I'm trying to let you understand. For example, we say that for us to know the magnitude of earthquake, assuming that maybe earthquake occurs in two different cities, okay, and you want to know the magnitude of the earthquake in city A, city B, and compare them, we can use this formula: m1 minus m2 is equal to log base 10 of A1 over A2, where M1, M2 represent magnitudes, and then A represent the amplitudes. So if you are asked a question like this: an earthquake in city A had a magnitude of 6.5, while another city B had a magnitude of 4.5. How many times greater was the seismic wave amplitude of the earthquake in city A compared to city B? Now, again, it's not about me solving the question here, but I want you to see where logarithm comes to play here. So if you quote the formula, the substitution of the magnitude of the first city and the second city, you realize that I'm going to have log base A, log base 10, A1 over A2. That means the amplitude has not been given. But then if you further simplify this, and you simplify and you get up to this point, you need to just say that A1 over A2 is equals to 100. And so A1 is equals to 100 times A2. So what is the conclusion here? The conclusion here is that the seismic wave, okay, the seismic wave that, or the seismic wave amplitude of the earthquake in city A was 100 times greater than that of city B. At the end of the day, what I want you to understand is that logarithm was used in doing this calculation. So those who are working in geological department will understand this calculation so well. What about music and sound? Do we see need logarithm? Yes. In music, logarithms are used to convert the pitch of musical notes from the linear scale to logarithmic scale. This helps in understanding intervals and creating harmonic in music. Right. So again, if I give you a question and say maybe in this particular music we want to look at what happens to octave correspond to doubling of frequency. The formula that can be used to find the number of octaves between two notes is given as n is equals to log base 2 f of 2 over f of 1, where f of 1 is the frequency, f of 2 is the frequency of the lower note, and that of the higher note being the f of 2. And then the n is the number of octaves between the two notes. We are not doing music here right now, but what I want you to understand is that in music, calculating this, we need logarithm. And so if someone gives you a question like the frequency of the note A is 220 hertz and the frequency of note B is 880 hertz, how many octaves higher in note B than in note A? In doing these calculations, you need to apply logarithms. Okay, that is what we are trying to understand here. Then again, pH in chemistry. pH in chemistry. The pH scale, which measures the acidity or the basicity of a solution, is in logarithmic form. Each pH unit represents the tenfold change in the concentration of the hydrogen ions in solutions. If you have water and you want to know maybe the acidity of the water or the alkalinity of the water, you can do this calculation using logarithms. Okay, so the pH of solution is calculated using the formula pH is equals to negative log base 10 of the hydrogen ions, where the H plus here is the H plus here is the concentration of the hydrogen ions in moles per liter. So that if a question comes like this, a solution has a hydrogen ion concentration of 1.0 times 10 raised to the power negative 4 mole per liter, what is the pH of the solution? Here, in the course of doing this calculation, you need logarithm to make your conclusion or your answer clear. So logarithm is so important in our daily lives or in world of work. Okay. Again, if you want to know more about biology and medicine, maybe in terms of the bioinformation, that is, we are saying that logarithms are used to sequence alignment, analyzing DNA sequence, and quantifying gene expressions. All right. So in biology, scientists use the logarithm to analyze gene expression levels. For example, gene expression is often reported as the log base 2 of the fold change in expression between two conditions. Okay, so the formula comes in like this, and you see that logarithm comes to play also over here. And if you look at this question, in the course of solving it, you still need logarithm to make this answer come so clear for interpretation or for biological purposes. Finally, let's also say that population growth, we use logarithmic scales, okay, to study population growth and the rate of change in population over time. In dealing with population, we also have formula like this. So those of you who in future you enter into social works where you do calculate population or working with Ghana Statistical Service and you want to know the population rate and stuff, you'll be using a formula like this. And so far as we have this exponent here, in the course of calculating this, you will need logarithm in dealing with this. So for example, a town has an initial population of 5,000 people and grows at a rate of 4% per year. How long will it take for population to reach 10,000? In the course of doing this, you will need to quote a formula like this and you make substitution and solve this question. You end up getting your value and you need logarithms to understand the concept. Okay, so and here we use natural log. Take note, natural log, and it's all about logarithm when you study it. As we are progressing in the series of logarithm, we'll mention it along the way. I'm sure this will give you a fair idea to know that logarithm that you are studying is not for fun, but it will help you in doing a whole lot of work in the field of studies. I'm sure this has been a blessing to you. Thanks so much for watching. Stay blessed.